Okay, hi everybody. This is the beginning of our final exam review. We're looking at number 1 on your review packet. So what should be our first step in solving for x here? What should we do first? Alexis? What should we do? All right, so subtract 1 from both sides. So I'm going to have log to the base 5 of 3x equals 3. What should be our next step here, Stormy?
Rewrite it exponential.
Rewrite an exponential. So what's that going to look like? What raised to the what equals what?
3 to the 3x.
3 to the 3x. Do people agree with that?
No.
What should be our base?
5. 3 equals 3x.
So we want 5 raised to the 3 equals
3x.
3x. So 5 to the third is 125. So I have 125 equaling 3x. And then we're going to divide both sides by 3 to get our answer. And so we're going to end up getting 125 over 3 or 41.6 repeating. Are we okay with this? All right, and how about number 2? Solve the exponential equation. For this one, what should we do as our first step here, Sam? All right, subtracting 3 from both sides. We get 2 raised to the 5x equals 6. And then what, Mackenzie? Can we rewrite this from exponential form into log form?
Yeah.
How is it going to look? Log to the base what of what equals what? What are you going to fill it?
5 to 6
Log to the base 2 of 6 equals 5x. Everybody okay with this? All right, and then you're going to look at your calculator. You're going to do log to the base 2 of 6 on your calculator, and then you are going to divide both sides by 5. So we should have log to the base 2 of 6 over 5. And that should turn out to be about 0.517. Can you confirm that? Okay, let's take a look at number 3. Tony invests $6,000 at 5.5% interest, compounded continuously. How much will he have in the account at the end of 10 years? So we are using this A equals P times E raised to the RT formula. And in this case, what are we plugging in for P and what are we plugging in for R? What are we plugging in for T max?
The principal is 6,000.
Okay.
The R, the percentage.
Yes, written as a decimal. So what's 5.5%?
0.05.
Okay, 0.055. And the number of years?
10.
10. So go ahead, grab your calculators. What is 6,000 times E raised to the 0.055 times 10? You're going to use your E to the X button on your calculator. So if let's see, I'm going to add a calculator page. So I want 6,000, I would say times, I'm going to use this E to the X button right here, and I want 0.055 times 10. So I'm getting, whoops, oh, that's bad. I'm getting, oh my gosh. Did you get $10,399?
Yep.
Yes.
Approximately. Okay. All right. Let's take a look at number. Oh, that's our answer here. All right. So let's take a look at this one. For this one, you're describing the transformation from e to the x, e to the opposite of 2x plus 10. So what kind of transformations do we have here, Michaela? Is it shifting, stretching, reflecting, compressing? Up 10. Okay. What else?
horizontal compression of -1/2.
All right, because the 2, it's a horizontal compression of, well, let's just say of 1/2, right? Because if there's a number being multiplied by the x, then you have to flip it, and it's going to be a horizontal stretch or compression. So in this case, we flip the 2, we get 1/2 to have your horizontal compression. And then what about this negative here? Since we have a negative with the x, what is that going to do, Patrick?
To make it by, wait, hold on. Cross x.
So it's going to,
Y.
which? It's going to reflect over the x-axis or reflect over the y-axis?
X.
Do people agree? Now Patrick just changed his mind again. So if you make the x itself negative, like here, we're making the x part negative, that's a reflect over the y. So this is a reflect over the y-axis. So your transformations are reflect over the y-axis, horizontal compression of 1/2, and a shift up 10. Are we okay with this one? Let's take a look at this one. It says write the transformation based on the following. The function f of x equaling 6 to the x, that's our parent function. It's translated 4 units to the right, reflected over the x-axis, and vertically compressed by a factor of 1/7. Nina, what can you do for the translated 4 units to the right?
It'll just be, I think it's in with like 6 to the x minus 4.
So you want to do right with the x? You want x minus 4 like that? Do people agree? Nina doesn't feel confident. Should she be? Look okay? Confidence is high. All right, what about the reflecting over the x-axis? Do we make the x negative or do we make the whole function negative, Stormy? Whole function?
Yeah.
So we want to make the whole function negative, and then I want to do a vertical compression by a factor of 1/7. Emphasis on the word vertical. So what do we do with that, Paul?
You do the,
Do the what?
by the whole thing by 1/7.
The whole function gets multiplied by 1/7. I'm going to squeeze that in right here. So I get negative 1/7 times 6 raised to the x minus 4. Are we okay with this? All right. By the way, we ran this off mostly on white paper, this review. But I wish we had run them off on gold paper, because treat this like gold. You can do every problem on this packet. You will be in good shape on the final exam, okay? So take this exam review very seriously. Be paying attention as Ms. Bell and I are doing our best to help you through each of these problems. All right, let's take a look at number 6. One more transformation problem. We're doing f of x equaling ln of x. Write the transform function that has been shifted up 3 units and reflected over the y-axis. Jake, what should we do?
Shift it up to plus 3.
So plus 3 at the end?
Yeah.
Okay, so I want ln of x plus 3, and I want to reflect it over the y-axis with the x. So I want a negative with the x. So I should have ln of opposite of x, and then plus 3. So here's our function. Are we okay with this? All right, so everybody hold up your calculator. You got your calculator with you today? All right, good. Let's get them warmed up and ready for number 7. We're doing number 7. A research study showed that the rate of calf survival in a Yellowstone elk herd depends on the depth of the snow in the spring. If the snow is about 5,000 millimeters deep, the rate of survival is about 0.9 calves per 100. Okay?
That's not very good.
No, it's not. But it gets worse, because if the snow is deeper, less are going to survive. So if it's 6,700 millimeters deep, then the survival rate's about 0.3 per 100 cows. And if it's 8,250 millimeters, it's about 0.17 that survive out of 100 cows. So find an exponential function to model the data. Use the model to predict the calf survival rate. So join me, if you would, in going to your calculator. We are going to go to a list and spreadsheet page, and we're going to call this top one, like, I don't know, you can call it D or depth, okay? I'm calling mine depth, and when you fill it in, I already had these entered from last class, so that's 5,000, 6,700, 8,250. Are we agreeing with this? And then here, we're going to call this S, or survival. I called mine survival last class, which is why it's looking nice and bold, because my calculator remembers that I had that, and I'm going to fill in the data there. Are we okay with this? All right, at this point, I am going to add a calculator page so that I can do exponential regression on this. All right. We have our data entered. So I'm going Control, Doc, Calculator. I want to go Menu, Statistics. I want Stat Calculations, and I want Exponential Regression. When I do that, I choose my X list. I called it Depth. And my Y list, I called Survival. Notice it's storing it at F2 for me. That's important because we're going to need that for our follow-up question. Okay, so here's the model that I'm getting. I have A is 10.99. The B here is 0.999485. So my answer for this problem should be, I can scoot this down a little bit, should be 10.993 times 0.999 raised to the x power. Something like that? Okay, and then it asks the follow-up question, what about if the depth is 4,000? So you can either, you get a choice, you can either plug in 4,000 right here, because x is our depth, y is our f of x, our survival rate, or in case you've never used the trace feature on your calculator, let me show you how that works. So I'm going to add another page. I'm going to add a graphs page. Remember I said it stored it in F2, so I'm going to do an up click to see my function. There it is, F2. I push enter. I'm not really seeing my function too much, but that's because my x is my survival rate. That only goes up to like 1. Hello. And I can make this 0. Come on. Okay, and then I know that this number over here can go to, I don't know, how about like 10,000? So there's my function. All right, but I can do menu, trace, graph trace. Have you tried that before? Give me a little nod. Did you ever try that? No, nobody, a couple people. All right, so with this, I can just type in 4,000 and it'll take me right to my answer. All right, 1.4. So that should be our answer for this part. Estimate based on, okay, so it should be 1.4 per 100 cows as our answer.
After you did the graph trace, what did you do?
I did menu, trace, graph trace, and then I just typed in 4,000 for the depth. And it brought me right to that ordered pair, and it gave me the ordered pair at the bottom. Okay, let's take a look at number 8. Now we're stepping into chapter 5, so this is variation problems. We're in section 5.1. So for number 8, it says y varies directly as x equals 5 and y equals -3. As soon as you see that y varies directly as x, what should we be writing down as soon as we see that? Michael. As soon as you see y varies directly as x, we should write down what? Y equals, we need some help. Michael, phone a friend. Patrick.
From Paul.
Paul.
Y equals kx.
Thank you, Paul. All right, so we want to write down y equals kx, right, as soon as we see that. And we're going to plug in 5 for x and -3 for y. So I'm going to have -3 equals k times 5. I need to divide both sides by 5 so I can solve for k. And I end up getting k equaling -3/5. I'm not done yet, though, because my model, I have to plug that -3/5 in right here for the k. And so my model is going to be y equals -3/5 x. Are we okay with this? All right, and then when it says find the value of x when y equals -8, we're going to plug in -8 for the y right here. So I'm going to have -8 equals -3/5 x. And I need to solve for x, so I probably multiply by -5/3, the reciprocal. And when I do that, I end up getting 40/3, which is about 13.3 repeating. Are we okay with this? Let's try another variation problem. This one is a joint variation problem. It says the volume V of a rectangular prism of a particular height varies jointly as the length L and the width W. All right, stop. Let's just take that much. So if I have that much right here, and I want to write that in some kind of a model form, Sam, what's that going to look like? Instead of y equals kx, I'm using what variables? Okay, so I'm going to write v equals L times W, but I need my constant also, right? Whatever my times K. All right, with this in mind, we're going to plug in what, where? It says V equals 224 cubic feet when the length is 8 and the width is 4. So, Jackie, what should I be plugging in? Okay, so that's 224 equals the, what, 32K? So I divide both sides by 32, and I get what for my K value? X? 7. All right, so my K value is 7. My model is going to be V equals 7 times L times W. With that in mind, we're ready to plug in, then we're ready to answer the question, which is right here. Find the length when the volume equals 210 and the width equals 5. So I'm going to plug in 210 here for V, and I'm going to plug in 5 right here for W, and I'm going to solve for L. Patrick's okay? What'd you get for your answer? Do you need to sit up closer?
210.
Because it looks like you're really struggling to see what's up here. I got nice seats right up front. You're in the cheap seats back there.
Is it 6?
Is it 6? Do people agree? Okay, so in this case, if you plug those things in and you solve, you get the length is 6. All right, how about this one? For this one, so will this let me take a picture? Probably not. Maybe. No, I don't know what this is. Oh, thank you, but that's not what I wanted. That's not what I wanted. How about this? Send to clipboard. Oh, okay, so here we're dividing. So if we see dividing by a fraction, that's the same as what? Multiplying by the reciprocal, which means that I can rewrite this as 4x squared plus 15x plus 9 divided by 8x squared plus 10x plus 3 times, and I want to switch this around, the reciprocal is 2x plus 1 over x squared plus 4x. All right, in order to do this, I certainly don't want to multiply straight across right now. I want to factor as much as I can and then see if anything divides out. All right, so can I have, since it looks like a lot of product sum going on here, can I have all the ladies in the room factor this numerator, and can I have the gentlemen factor the denominator? All right, you're doing product sum. And while you guys are working hard at that, I will factor this denominator over here, so I can factor on x, and I have x plus 4. I'm done. I took the easy one. So, ladies, your product was 36, your sum was 15. What two numbers did you choose? 12 and 3. So you're taking out the 15x, and you're replacing it with the 12x plus 3x. And so when you did that, you had 4x squared plus 12x plus 3x plus 9. Factoring by grouping, And what did you get here?
4x plus 3, 10x plus
Because you factored out 4x and had x plus 3, and you factored out 3 and you had x plus 3. So you got 4x plus 3 times x plus 3. Ladies, do you all agree?
Yeah.
Yes? So let me write that in, 4x plus 3, x plus 3. Get rid of all that. This is 4x plus 3 times x plus 3. So we rewrote that. Gentlemen, you had 24 and 10. What two numbers did you choose?
64.
6 and 4. So you took out the 10x and you replaced it with a 6x and a 4x. So we have 8x squared plus 6x plus 4x. And it was what? Plus 3? And factored by grouping, what did you factor out of those two here, Michael?
4x.
Maybe you put them in a different order. What can I factor out of 8x squared plus 6x?
2.
2x? And what's going to be left?
4x plus 3.
All right, and then what can I factor out of 4x plus 3? 1, so I'm going to write plus 1, and what's going to be left?
4x.
So what's your final factored form?
2x plus 1 and 4x.
Gentlemen, do you all agree? So I got 4x plus 3, 2x plus 1 right here. Get rid of this. So this one here factors into 4x plus 1 and 2x plus 3. I didn't do that right, did I?
I don't know.
should be 2x plus 1.
I didn't even remember from up above. So it was, let's try this again. It was 4x plus 3 and a 2x plus 1. Okay, so now I can say what divides out. Well, this 4x plus 3 here divides out with this 4x plus 3. And the 2x plus 1s. Is that right?
Yeah.
And so that leaves our final answer should be what? X plus 3 is the only thing left in the numerator over x times x plus 4 in the denominator. Are we okay with this? All right. All right, that was number 10. And let's take a look at number 11. Now we are subtracting. In order to subtract fractions, Patrick, we have to have what?
Common denominator.
Common denominator. So in order to find the least common denominator here, we might want to factor first. What does x squared minus 16 factor into?
Plus 4, minus 4.
X minus 4, x plus 4. So we rewrote that. And I already have an x minus 4 here. So what is my least common denominator? X plus 4, x minus 4. So I already have an x minus 4 in this fraction. So what do I need to multiply this fraction by in order to get the least common denominator of x plus 4, x minus 4? All right, so I got to multiply top and bottom by x plus 4. All right, and when I do that, I am going to want to distribute this by, so I'm going to have 2x minus 8 over x minus 4x plus 4 minus 5x, what, plus 20 over x minus 4x plus 4. Good news. We have common denominators now for our two fractions so that we can add them. We can just add the numerators together, keep that same denominator. But bad news. Bad news is, maybe not that bad, but we do have a minus, so we do need to remember to distribute that negative to both of these. So I'm going to have 2x minus 8 minus 5x and then minus the 20. Are we okay with this? And when we combine like terms in the numerator, we're going to get what, Nina?
Wait, what did you say?
Combining like terms here in the numerator.
So you get negative 3x and negative 28.
All right, negative 3x minus 28. Are we okay with this? Over our denominator of x plus 4x minus 4. All right, let's take a look at number 12. For number 12, we're identifying the domain, the zeros, and the asymptotes in the graph. So let's start out with the domain. In order to find the domain, we need to set the what equal to 0. The denominator. Set the denominator equal to 0. All right, why? Because the domain is going to be all real numbers except when we plug in a number that makes our denominator equal to 0, we've got to kick that number out because we're not allowed to divide by 0. Okay? So if we're trying to find the domain, it's going to be negative infinity to positive infinity, except x cannot equal what for this first fraction? 0. So x cannot equal 0. What about this one? Well, for this one, we're going to have to factor this x squared minus 4x plus 3. So what does this factor into? The product is 3, sum is negative 4. What two numbers will work? Negative 3 and a negative 1, so I get x squared minus 3x minus 1x plus 3. Factor by grouping, and I can factor out an x. What's left? X minus 3. And I can factor out what out of the negative 1x plus 3? A negative 1, and then I get x minus 3, so these match. So it should factor into x minus 3 times x minus 1. So I rewrote that denominator. So now I can answer the question about the domain. The domain is going to be negative infinity to positive infinity, but x cannot equal what? So the domain for this one now is negative infinity to positive infinity, but x cannot equal
1 or 3.
1, and x cannot equal 3. Are we okay with this domain for this problem, this domain for this problem? All right. Okay, and let's talk about, copy, paste. Okay, let's talk about, we found the domain, let's talk about the zeros. In order to find the zeros, we need to set the what equal to 0. The numerator. We set the numerator equal to 0. And so in this case, we're going to factor this numerator. You do product sum, and this is going to factor into x here. I need a 4 here and a 3 here. And I think this is going to be minus, that's going to be a plus. You could check me with product sum. But if I do factor it like this, then what numbers make my numerator equal to 0? Negative 3 and a positive 4. So my zeros for this first one are going to be negative 3. I'll say negative 3 and 4. Those are my two zeros. What do we mean by zeros?
Where it crosses the x-axis.
All right, it's where the graph is going to cross the x-axis. Zeros are any x value that's going to make your function equal to 0. So a function that's a fraction, like our function is here, a fraction is going to be equal to 0 when its numerator is equal to 0. So that's why we set the numerator equal to 0. For this one over here, we would need to do product sum on this. So product is 8, sum is 9. What two numbers will work? 8 and 1. So I'm going to take out the 9x and replace it with 8x and 1x. And factor by grouping here, Jake, I'm going to get what? What can I factor on the first? 2. 2. Can I factor out 2x?
Yeah.
All right, and then what's going to be left? X plus 4. And then what can I factor out of a 1x plus 4?
1 and x.
So just factor out 1, and then you're going to be left with x plus 4. So what's it going to factor into? 2x plus 1, x plus 4. So this is 2x plus 1 times x plus 4. So that means that my zeros for this problem are going to be what? So it's going to be -4 and -1/2. If we set each of these equal to 0. All right. Now, what about asymptotes? Let's see, add a page, paste. So if we're looking for asymptotes, let's talk about vertical asymptotes first. Vertical asymptotes are going to be when your when your denominator is equal to 0. So it's going to be the x value that makes your denominator equal to 0. So in this first case, we said we were kicking 0 out of the domain, so x equals 0 is the vertical asymptote. For this one, the vertical asymptote is going to be, there's going to be 2 of them. What are my vertical asymptotes going to be for this problem? Let's go back a page, 2 pages. We said that we were kicking out 1 and we were kicking out 3, right, from the domain. So those are going to be our vertical asymptotes. X equals 1 and x equals 3. For the horizontal asymptotes, that's going to be y equals something, but if our numerator degree is greater than our denominator degree, then there is none. So for this one, there's none. And for this one, since the degrees are equal, they're both 2, it's just going to be y equals leading coefficient over leading coefficient. So y equals 2 is the horizontal asymptote for this one. All right, we will pick this up next class. Meanwhile, before next class, try and do as many of these problems as you can. Treat this packet like gold. All right, have a good day, everybody. See you Wednesday. Yes.